Welcome to RaWMachines, your ultimate ticket to exploring the most impressive industrial processes across the globe. From the depths of mysterious forests to world-class timber mills, every single stage of production demands absolute precision. What are the hidden secrets behind top-tier wood processing? And how exactly is a massive ancient tree utilized down to the very last speck of sawdust? Let's step right into the journey of transforming raw timber into invaluable material, starting right now. Before us stands a giant that has survived for centuries, a massive cedar tree with a trunk diameter of up to 4.5 meters. This is more than just an impressive number. Its sheer size exceeds the limits of conventional logging methods, pushing both machinery and human skill to their absolute limits. To bring it down, the logger starts with a specialized cut, allowing the saw to reach deep into the trunk and its supporting roots. As work progresses, an unexpected discovery emerges. The tree is hollow inside. While this reduces the amount of wood that must be cut, it also makes predicting the fall much more difficult. The crew then uses a technique known as tickling, carefully weakening the remaining fibers that keep the giant standing. Instead of forcing it down, they patiently guide the tree toward its final fall. When the last fibers finally give way, the giant crashes to the ground with tremendous force, shaking the forest around it.
We'll stand the stump, Daniel.
Bringing down this 4.5-meter colossus stands as the ultimate testament to the grit and mechanical intellect of American loggers. To them, each fallen giant is not an act of extraction, but the continuation of a legacy where raw human capability is channeled toward building a sustainable future.
Holy shit.
Once the tree has been brought down, it is still a long way from its final destination. Weighing as much as 30 tons, the massive logs are loaded onto specialized logging trucks for transport out of the forest. The journey to the mill is far from easy. These trucks must navigate steep hillsides, tight switchbacks, and rough forestry roads carved through challenging terrain. The job demands highly skilled drivers who can maintain precise control of their vehicles while hauling such enormous loads. The first stop on our journey is the Hancock Lumber facility. With a rich history spanning over 175 years, this is far more than just a processing plant. It is a profound family legacy, earning it the reputation as the world's largest manufacturer of eastern white pine. Hancock's core philosophy is crystal clear. If a tree takes a century to grow, then humanity must not waste a single fiber of it. The process begins out in the open-air log yard as heavy-duty trucks, heavily loaded with raw logs, roll into the facility. Here, specialized log handling cranes and grapple loaders systematically unload the timber, stacking them into neat, organized decks ready to be fed directly into the primary production line. The first log enters the debarker, encountering a system of continuously spinning cutter heads. Stripping away the rugged outer bark does more than just protect precious saw blades from abrasive dirt and debris. It provides the engineers with an unobstructed view of the log's entire structural makeup and unique characteristics before the very first breakdown cut is made. This is one of the most important stages in the entire mill. Before cutting begins, a laser system scans the entire log and creates a detailed digital model. The computer then calculates the optimal sawing plan to obtain the maximum amount of finished lumber while minimizing waste. Under the operator's control using a joystick, the log is fed through a giant bandsaw. The first cuts appear, transforming the round trunk into boards and a squared timber section at its core, known as a cant. Once the cant has been formed, it moves on to the gang saw. Here, a single saw blade is no longer enough. Instead, dozens of blades operate in parallel, cutting simultaneously as the timber passes through. In a single pass, the large timber section is transformed into multiple boards of uniform thickness. This system dramatically increases production efficiency while maintaining an exceptionally high level of precision. The freshly sawn boards still retain their natural curved edges, along with traces of bark along the sides. At the edger, a computer-guided system determines the most efficient cutting pattern, trimming away the excess material and producing clean, straight, and uniform edges. This step plays a crucial role in maximizing the commercial value of every board. Next, an automated sensor system dynamically scans and grades each piece of lumber, sorting them by size and quality into their corresponding storage bins. Even after sawing, the wood still contains a significant amount of moisture within its cellular structure. To ensure long-term stability, the boards are loaded into massive industrial kilns for 3 to 4 days. Inside, temperature and humidity are carefully controlled by computer systems. As the moisture is gradually removed, the wood becomes more stable and less prone to warping, shrinking, or cracking once it is put into service. Now comes the planing phase to smooth out the surface. High-capacity planers shave away an incredibly thin layer of material from the face of the boards, instantly revealing the vibrant natural coloration and striking grain patterns hidden beneath. In the final stage, experienced graders inspect each board by eye, assigning quality grades and marking them by hand before packaging. Just days earlier, these were towering trees standing deep within the forest. Now, they have been transformed into high-quality building materials, ready to be shipped to construction sites and customers around the world. At Hancock Lumber, that journey reflects the seamless combination of natural resources, human expertise, and modern technology, working together to turn raw timber into products that support everyday life. Leaving Hancock Lumber behind, our journey takes us deep into the American South, home to the McDixen facility. Unlike massive volume-driven operations that focus solely on maximum throughput, McDixen preserves the raw essence of traditional sawmilling, where modern machinery operates hand-in-hand with decades of human expertise. The facility's core philosophy stems from a simple, unyielding perspective. To create a truly premium product, you must first understand and respect the natural characteristics of every individual tree. Each day, dozens of log trucks queue up and roll into the facility. These freshly harvested logs, hauled in from various timberlands, are quickly routed to the sorting yard. This is where the grading process begins. Simply by evaluating the coloration, grain pattern, and overall shape of the trunk, the yard masters can instantly determine which raw material is best suited for structural building beams, high-end furniture, or pulp production. From the sorting yard, the logs pass through a massive rotary debarking drum to strip away their rugged outer armor. Immediately afterward, an advanced 3D laser scanning system performs a digital dissection. The computer clearly maps out every growth ring, hidden knot, and even internal hollows. This data allows the AI to optimize the sawing pattern, ensuring that every single cut extracts the highest possible value while driving material waste down to the absolute minimum. Once the laser scanning process is complete, the log moves into the primary cutting area, where the true value of the timber begins to be unlocked. The first stage takes place at the band mill, equipped with a thin, high-speed blade. The machine delivers precise cuts while minimizing the amount of wood lost as sawdust. As the log passes through the system, its round shape is gradually transformed, revealing a squared timber core known as a cant, the most valuable section of the log. From there, the cant is sent to the gang saw. Unlike a single saw blade, this system uses multiple blades operating in parallel at the same time. In just a matter of seconds, a large timber section can be divided into a series of boards with uniform thickness. The combination of speed and precision allows the mill to maintain high productivity without compromising quality. Next comes the edger. Although the boards have already been formed, they still retain the natural curved edges of the original log and, in some cases, traces of bark. Computer systems analyze each board and determine the cutting pattern that delivers the greatest value. The saw blades then adjust automatically, trimming away excess material and producing perfectly straight edges. The final step in this area is the trimmer. Here, the ends of each board are cut to standard lengths, such as 8, 10, or 12 feet. At the same time, Sections containing major defects or imperfections are removed to ensure consistent product quality. One of the most remarkable aspects of the process is that almost nothing goes to waste. Offcuts, wood scraps, and excess material are collected immediately and put to use elsewhere. Some are processed into wood chips for the paper industry. Others are turned into biomass pellets or used as fuel to help power the mill itself. In just a few closely coordinated steps, a raw log has been transformed into precisely sized lumber, ready for the next stage of finishing. After sawing, the boards are transferred to an automated bin sorter system. Its job is to sort and group lumber of the same dimensions into dedicated stacks. By organizing the material at this stage, the mill can streamline both the drying process and long-term storage. Next comes stacking. As the lumber is piled into bundles, the automated system places thin spacers known as kiln sticks between each layer of boards. They create critical air gaps that allow uniform airflow to circulate through the pack, ensuring that heat and humidity are evenly distributed across the entire lumber stack. After stacking, the lumber is transferred into the kiln dryers, where the entire process is fully regulated by a computerized control system. The temperature, humidity, and airflow velocity are continuously modulated to ensure that moisture is drawn out of the wood at a perfectly uniform rate. Upon completing the cycle, the lumber's moisture content is successfully brought down to approximately 12 to 15%. This is the ideal target range to mitigate warping and guarantee long-term dimensional stability during end-use applications. Once the drying cycle is complete, the lumber packs are transferred to the planing mill, the final step before becoming finished commercial products. Here, the timber passes through a high-capacity surfacer capable of machining all four sides simultaneously. High-speed spinning cutter heads shave off a micro-layer of material, only a few millimeters thick, leaving the surfaces smooth, uniform, and clean. At the same time, this planing action brings the lumber down to its exact required nominal and actual dimensions. The rough, coarse boards from the sawmill now take on a highly refined appearance. With every pass through the planer, sharp edges are squared, faces are flattened, and the natural grain patterns of the wood are brought into sharp relief. Immediately following this, an automated quality inspection system goes to work. Laser sensors continuously scan the dimensions, flatness, and structural accuracy of each individual board as it advances along the conveyor system. Any product failing to meet strict quality thresholds is instantly flagged for trimbacks or downgrading. Each compliant piece of lumber is then stamped with its own unique identifier code, allowing the facility to track the product's entire manufacturing history. At the end of the production line, automated robotic arms stack the boards into tight bundles on pallets, wrap them in protective packaging, and print a tracking QR code prior to staging. At this point, the transformation journey is complete. From raw, freshly harvested timber in the forest, the wood has been converted into uniform, high-grade products ready to serve the construction sector, the furniture industry, and export markets. Looking at the neatly strapped lumber packs, it is hard to believe they were once just rugged logs standing out in the woods. Leaving the United States behind, our journey takes us to the Baltic region of Northern Europe, where the timber industry plays a pivotal role in Europe's green energy strategy. Here, Woodmill Latvia has developed a specialized production model focused entirely on a product that might seem deceptively simple: firewood. The process begins with the palax. Sensors measure the size and shape of each log before a hydraulic cylinder, capable of delivering nearly 20 tons of splitting force, divides it into uniform pieces of firewood. The firewood. What makes this system particularly remarkable is that it is powered by the mill's own byproducts, including bark, sawdust, and wood chips, creating a highly After approximately 3 days of drying, the moisture content is reduced to around 15%. The result is a cleaner burning fuel that produces more heat while generating significantly less smoke. Before leaving the facility, every shipment receives a QR code for full traceability, allowing its entire It is a reflection of the Nordic approach to manufacturing, not simply doing the job right, but doing it with exceptional precision and attention to detail. Woodmill Latvia demonstrates that even the smallest pieces of timber can be put to valuable use, helping create a sustainable production model with emissions kept to an absolute minimum. When looking at a finished piece of lumber, very few people think about the long journey it has traveled. From a tiny seed in the wild forest, a tree takes decades, sometimes even centuries, to reach maturity. Yet, it is only when it steps into the human world that its true journey begins. Throughout this episode, we have followed massive timber logs from the forests of America, witnessing the sheer skill of loggers as they handle ancient trees weighing tens of tons. We have traveled down treacherous hauling routes and stepped inside state-of-the-art facilities like Hancock Lumber and McDixon, where laser technology, automated systems, and high-speed production lines transform raw material into high-value products. We also caught a glimpse of a different side of the timber industry at Woodmill Latvia, where even the smallest scraps of material are reclaimed to generate biomass energy. Over there, the concept of waste simply does not exist. Every single part of the tree trunk is given a brand new role to play. What makes this fascinating is that despite the differences in scale, technology, and final products, every single facility we visited shares the exact same philosophy. It is a commitment to extracting the absolute maximum value from what nature took decades to grow. This is driven not just by economic efficiency, but by a profound respect for this precious natural resource. Today, the modern timber industry is no longer merely about felling trees and sawing wood. It has evolved into a sophisticated blend of forestry science, mechanical engineering, digital technology, renewable energy, and sustainable development. While the machinery grows smarter by the day, the human experience, creativity, and accountability driving them remain irreplaceable. Perhaps the greatest value of wood does not lie in the houses it builds, the furniture it crafts, or the energy it generates. Its true value resides in the story carried within every single grain, a story of time, of nature, and of humanity's relentless effort to transform a gift from the forest into something meaningful for our lives. Thank you for listening to the end of our story. If you love videos like this, please hit like, share, and subscribe to the channel so you won't miss any of our upcoming journeys. RaWMachines says goodbye, and we'll see you next time.